Okay, today we'll discuss a new chapter of macroeconomics. It's about elasticity. Of course, elasticity is very important topic in macroeconomics. Uh, Elasticity means, uh, uh, responsiveness of, if we're talking about the price elasticity of demand, we actually mean the responsiveness of the quantity demanded to changes in the price. So here we're going to basically derive a formula for calculating the price elasticity of demand. Remember that when we examine the demand function, usually in examining the demand function, usually economists are very interested in how the quantity demanded responds to changes in price and to changes in certain other ceteris paribus conditions. If we take the demand function, we know that in addition to the price or the only price, the price of the good in question, the demand, also depends on other factors uh, such as the income, the price of substitutes, the price of complements, and other, goods, such as the price of, or preferences. So all these factors determine the demand of a good. So as you can see, for instance here, the quantity demanded of good B is a function of the price of the good itself plus ceteris paribus factors or ceteris paribus conditions, such as the income, I is income, PR is preferences, PS is the price of a substitute, PC is the price of complements. Price of a substitute and the price of a complement are, called, prices of related goods and services. Okay, or prices of related goods and services. Basically, what we mean here, the price of substitutes, of substitute goods, and the price of complement goods. So it is very possible to determine the how quantity demanded of good B, of course, respond to change to a change, of course, to a change in any of the independent variables by holding all but one of them fixed. In other words, if I want to find the the elasticity or how quantity demand responds to income, then what I do, I hold the rest of the ceteris paribus condition fixed and only focus on income. So here, in this case, I will have the price elasticity of income, okay, or income elasticity of demand, okay. If I want to, talk about how the quantity demanded of good B responds to a change in the price of a substitute, then I'm talking about cross elasticity of demand. These will, as we progress in this, in the explanation, we will come across these, elasticities, these price elasticities. Now, so as I said, if you want to, see how to quantity demand of good B respond to a change in any of the independent variables. These are independent variables: price of good B, income, price of preferences, PR, price of substitute, PS, and the price of complement, PC. So these are, independent variables, and the quant demand of good B is the dependent variable. So that quant demand of good B depends on all these, in addition to its own price, that is the price of good B, it depends also on the other ceteris paribus conditions or other ceteris paribus variables such as income, preferences or taste, price of substitute PS, and the price of complement PC. Now, the price elasticity. So now we can define the price elasticity of demand as it's a measure of the responsiveness of the quantity demanded to changes in the price. This is the definition of price elasticity of demand as it's a measure of responsiveness of the quantity demanded, to changes in the price. So the price elasticity of demand of good B is a measure of responsiveness of the quantity demand of good B to changes in the price of good B. Now, the formula is, of course, as you can see, the price elasticity of demand is given by this formula, which is the percentage change in the quantity demand of good B over the percentage in the price of good B. So, and this is basically the difference between the price elasticity of demand and the slope. Slope is determined in terms of a change. Okay, it is in terms of the change. However, when we talk about price elasticity of demand, we talk about percentage change. So that's the difference between a slope between A and B and a price elasticity of demand between, point A to point B. Okay, and as far as the price elasticity of demand, we're talking about percentage changes, and as far as the slope, we talk about change, which is the change of the variable along the vertical axis over the change of the variable along the horizontal axis. That is, it is the rise over the run. When we're talking about slope is the rise over the run, where the rise is the change in the variable along the vertical axis, and the run is the change in the variable along the horizontal axis. So this is the difference between slope and the price elasticity of demand. So this is the formula of the price elasticity of demand. We're going to denote the price elasticity of demand by the letter ED. So ED is the price elasticity of demand, ED, okay, which is the percentage change in the quantity demand of good B, okay, over, if we're talking about, the good B, the price elasticity of demand of good B, over the percentage in the price of good B. Now, here, as you can see, ED is the coefficient of the price elasticity of demand. Okay, remember that economists usually, to simplify the things, of course, because of the law of demand, which shows that there is an inverse relationship between the price and the quantity demanded, or a negative relationship, we will get always a negative, value of the coefficient of the price elasticity of demand. So economists simplify this by, having absolute value of the formula. Here we get the absolute value of this. We can see the absolute value here, okay? So that always we will get a positive value of the price elasticity of demand. So always, when calculating the price elasticity of demand, of course, we will, take the absolute value of the formula here of the values to get a positive value. So a percentage here, this means percentage. ED is the coefficient of the price elasticity of demand. Delta is used is a Greek letter which is called delta. It is usually used to denote the change. Okay, and quantity demand of good B. This is the QDB, the quantity demand of good B, and delta, of course, it means the change, and P P, it means the price of good B. As you can see over here, that already discussed this, of course, because of the law of demand, we have an inverse relationship between the price and the quantity demanded. So you will always get a negative value of the price versus the demand because of the law of demand. But however, by convention, economists, of course, simplify things by using the absolute value of the price elasticity of demand. And so, of course, you will get, when you get the absolute value, you will get a positive value. So if the value, when calculating the price of demand, we're going to have always a positive value. It is whether it is greater than 1, greater than 0, or a greater than 1 or less than 1. Okay, so the value is going to be, either greater than 1 or less than 1, but between 0 and 1. Here we're going to talk about later on where when the value is greater than 1, it's called elastic demand, and when the value is between 0 and 1, we're going to say it is we have an inelastic demand. Of course, use this formula, as I said, of course, when we play with this formula, try to simplify it, we come up, of course, percentage change in quantity demanded is, as you can see, is the quantity demand over quantity demand average. And the percent change in the price is a change in the price over the average. Okay? Of course, the percent change in the quantity demand is the change in quantity demand over quantity demand average times 100. And then the percent change in the price is that it is equal to change in price over the price average, of course, the average of the price, and then the 100 will cancel out, where quantity demand average is QD1 plus QD2 over 2. The average, you have, initial price, final price, we add them, we divide by 2, we come up with the average in terms of price, P1 plus P2 over 2, that's the average of the price, or QD1 plus QD2 over 2, the average of the quantity demanded. And then when this is 1 here, okay, from here, of course, when we do the simplification, we come up with this one here. Of course, when we plug, instead of QD1, delta QD1, which is QD2 minus QD1 over QD average, that's what you get, over change in P is P2 minus P1 over P1 plus P2 over 2. We cancel out the 2 here, we come up with this, cancel out the 100, and then after simplification, this one becomes here, and then this division of 2 ratios will convert them to multiplication. This becomes this one here, and this is the formula that you can use to calculate the price elasticity of demand, which is ED is going to be equal to QD2 minus QD1 over QD1 plus QD2 times P1 plus P2 over P2 minus P1, where P1 is the initial price, P2 is the final price, QD2 is the final quantity demanded, and QD1 is the initial quantity demanded. And so, as I said, it is, it's easier to use this formula to calculate the price elasticity of demand. Okay, we will, of course, apply this formula in a second. We'll use that formula to calculate the price elasticity of demand. Now, of course, we give an example to illustrate the concepts of calculating, the concept regarding the formula of the price elasticity of demand. We said the price elasticity of demand is the percentage change in the quantity demanded over the percentage change in the price. And we played with that formula until we, end up with a simpler formula, which is basically the ED, the price elasticity of demand, is equal to the, which is, as you can see, this is the formula that we ended up eventually which is QD2 minus QD1 over QD1 plus QD2 times B1 plus B2 over B2 minus B1. This is the formula that we will use to calculate the price elasticity of demand, which is the same as the percentage change in the quantity demanded over the percent change in the price. So we have an example over here, as you can see. It says, given the following graph, as you see, this is a graph of the demand curve. It's a downward sloping demand curve, and you have A, B, C, and D, Of course, the quantity demand is along the horizontal axis, the price is along the vertical axis, and the first question says calculate the price elasticity of demand between A, B, B, C, and between C and D. Okay? The reason I stated this question like this to find the price elasticity of demand between A, B, B, C, and C, D is to tell you that along the straight line demand curve, elasticity changes, from high value in the upper half of the demand curve to low value in the lower half of the demand curve. In other words, we move from highly elastic in the upper half to highly inelastic in the lower half of the demand curve. This is, we will show that later on when we discuss the price elasticity demand along a downward sloping demand curve. Now, let's calculate the price elasticity of demand between A and B. So, between A and B, as you can see, at point A, the price is 12, the quantity demand is 50, as you can see here. And at, at point B, the price is 10, the quantity demand is 100. So let's calculate the price elasticity demand between A and B. So moving from 12 to 10. So we say this is the formula, ED equal ED2 minus QD1. This is the final price. This is the initial price. The final price is what? We move from 12 to 10. So the final price is 10. So 10, this is the final quantity. And this is the initial quantity. Now, when we move from 12 to 10, so 10 is the final price. It corresponds to what? It corresponds to the quantity 100. And the initial price 12 corresponds to quantity 50. So it's going to be QD2 100 minus QD1 minus 50. 100 minus 50 over 50 plus 100. We just add the quantities times P1 plus P2, 10 plus 12, or 12 plus 10, same thing, over 10 minus 12. Remember, as I mentioned, that by convention, economists, take the absolute value of the price elasticity of demand so that you'll always get a positive value of the price elasticity of demand. So here, as you can see, after simplifying this, these values, we come up with 9 over minus 5. Take the absolute value, we get 1 point, here, I'm talking about here in the first one. This is between A and B. We come up of 3.66. 11 over minus 3. Of course, the absolute value of that, you get 3.66. Now, the price between B and C. Between B and C, ED, we do the same thing, use the same formula here, okay? And we plug the values, of course, we come up with 150 minus 100 over 100 plus 150 times 10 plus 8 over 8 minus 10. And then after simplifying these calculations, we'll come up with 9 over minus 5. Take the absolute value, get 1.8. Now, between C and D, ED is using the same formula over here, using the same formula here. Okay? We use the same formula, QD2, now 8 to 6. So 6 is the final price, correspond to 200. Correspond to 200. So we're going to have 200 minus 150 over 150 plus 200 times 6 plus 8 over 6 minus 8. Of course, do the calculation, take the absolute value here, we come up with 1. So, as you see, ED is elastic in that portion, okay? In the upper portion of the demand curve, and it is value decreases as you move down the downward sloping demand curve. This we will see that later on when we discuss the price elasticity of demand along a straight line, a downward sloping demand curve. Now, part 2 of the question says, calculate the slope of the demand curve between A and B, and between B and C, and also between C and D. Here I'm trying to show you that the price elasticity of demand is different than the slope of the demand curve. You know, here we have a straight line demand curve. The expectation is that, you know, the slope is the same. The slope is the same. So whether you move from A to B or B to C or C to D, the slope will continue to be the same. It's going to be minus because it is downward sloping, so the slope is negative, but it has the same value. But that differs from the price elasticity of demand, you know, calculating it between A and B, or between B and C, or between C and D, because it's going to be different. However, the slope is the same whether you calculate it from A to B, or B to C, or C to D. Now, let's prove this. Between A and B, the slope is change in the variable along the vertical axis, which is delta B, price, over the change in the variable over along the horizontal axis, which is delta Q. This is Q here, and this is B. So the slope is the rise over the run. The rise is the change in the variable along the vertical axis over the change in the variable along the horizontal axis. We do that one here, P2 minus V1, Q2 minus Q1, as you can see from A to B. So this is the final price, 10 minus 12, okay, over, you know, 100 minus 50. 100 minus 50, we come up with what? Slope is equal minus 1 over 25. Now, between B and C, of course, the slope is the change in the variable, is the ratio of the change in the variable, of the variable along the vertical axis over the change in the variable along the horizontal axis. So we got here, of course, 8 minus 10 over 150 minus 100, 150 minus 100. As you can see, 8 minus 10 over 150 minus 100, and you come with minus 1 over 25 is the same. As you can see, this one here is the same as the one. Also, it is the same here. So, calculating the slope between C and D, the slope is the same, is the, the ratio of the change in the variable along the vertical axis over the change in the variable along the horizontal axis, and we come up with 6 minus 8 over 200 minus 150 between C and D. Between C and D, 6 minus 8 over 200 minus 150, and we come up with minus 1 over 25. As you can see, the slope is the same. However, the price elasticity of demand differs between A and B, or between B and C, or between C and D. It differs. The values, as you can see, 3.66, now 1.8, and then 1 changes as you move along the straight line, the downward sloping demand curve. So, as you see, the slope of the demand curve between points A and B, and between points B and C, and between points C and D is the ratio of the change in the variable on the vertical axis to the change in the variable along the horizontal axis, as I said already. Of course, however, to calculate the price of demand, we divide the percentage change. We said the formula of the price elasticity of demand. We have already said that it's equal to the percentage change in the quantity demanded, okay, over the percent change in the price. So the value of the slope is the same between, any of these 2 points, A to B, or B to C, or C to D. And however, the price of demand, changes as we move along the straight line demand curve. Now we talk about different kinds of demand curves. So here we're going to talk and explain different kinds of demand curves. Of course, we're going to start with perfectly inelastic demand curve. What that curve says. Of course, a perfectly inelastic demand curve means that the price elasticity of demand is zero. In the real world, this kind of demand curve does not exist. Okay? So the perfectly inelastic demand curve takes place, of course, when the coefficient of the price elasticity of demand is zero. Okay? And the graphical representation of that demand curve is vertical. So we're going to have a vertical demand curve. So as you can see, whatever the price increases from B1 to B2, there is no change in the quantity demanded. The quantity demand does not respond to any change in the price. So in that case, we're going to have a perfectly inelastic demand curve. So it is represented graphically by a vertical demand curve. In the real world, that demand curve does not exist, but we have, approximation to that perfectly inelastic demand, which is the highly inelastic demand curve or relatively inelastic demand curve. Those can approximate the perfectly inelastic demand curve. So the second type of demand curve is the relatively inelastic demand curve. Of course, the coefficient of this demand curve, or the coefficient of the price elasticity of demand of this inelastic demand curve, is less than 1. Of course, the absolute value is going to be less than 1, or between 0 and 1. So graphically, this kind of demand curve is represented by more or less a steep demand curve, as you can see over here. This is a steep demand curve, okay? A sharp demand curve. This is a steep demand curve. As you can see here, when the price changes from B1 to B2, of course, from B1 to B2, okay, as you can see, the quantity, of course, the quantity demanded changes from Q1 to Q2. The price increases. As you can see, the percentage change in the price is greater than the percentage change in the quantity demanded. This is the percentage change in the quantity demanded. It's less than the percentage change in the price. So when we have an inelastic demand curve, of course, the coefficient of the price elasticity of demand is less than 1. Therefore, the percentage change in the quantity demanded is less than the percentage change in the price. Of course, the third type or kind of demand curve is the elastic demand curve. So the elastic demand curve is represented by a demand curve that is more or less a flat, not sharp, not steep, however, it's a flat. And the coefficient of the price elasticity of demand of the elastic demand curve is greater than 1. Of course, the absolute value. Of course, as you can see, this is the graphical representation of the demand curve. It is more or less a flat demand curve. As you can see, when the price increases from P0 to P1, the quantity demanded increases. Of course, when the price increases, of course, the quantity demanded decreases from Q0 to Q1, and the percentage in the quantity demanded is larger than the percentage in the price, as you can see over here. Okay. The fourth type of demand curve is the unit elastic demand curve. Here, the coefficient of the price elasticity of demand is equal 1. That means the percentage change in the quantity demanded is equal to the percentage in the price. The graphical representation, of course, the mathematical term for the curve of this demand is a rectangular hyperbola. As you can see, a rectangular hyperbola. This is, the best, demand curve to represent this type of demand, which is the unit elastic demand. As you can see here, the percentage in equal demand is the same as the percentage change in the price. Okay. Now the last kind of demand curve is the perfectly elastic demand curve. The perfectly elastic demand curve, is a demand curve that has a coefficient of the price elasticity of demand equal to infinity. It's represented by a horizontal demand curve, as you can see here. So this demand curve tells us that at a price of $10, suppose, consumers are willing to purchase all units of the goods presented by the seller. However, when the price it changes by a tiny amount, let's say here we said 10, if the price says $10.05, then consumers, this tiny change, a small change in the price will cause an extremely large change in the coin demanded, from purchasing, everything to purchasing nothing. Okay, this is basically, the perfectly elastic demand curve. Of course, an example of this sometimes is two soda vending machines, standing, next to each other, and when one, of course, to purchase any bottle of Pepsi from one vending machine, you have to insert, let's say, $1. And the other one, which is just next to this, you have to put $1.10 or $1.05. Then, of course, a consumer definitely, when he sees the difference in the price, even though it is so tiny difference, he will completely buying nothing of the Pepsi from the other vending machine, because a tiny change in the price will cause the consumer to purchase nothing.